August 24, 1916. High Wood, France. Captain Graham Seaton Hutchison checks his watch. 23 hours continuous fire. The 10 Vickers guns of the 100th Machine Gun Company haven't stopped. Barrels glow cherry red in the darkness. Water in the cooling jackets boils violently, steam hissing into the night. His gunners swap barrels every few minutes, hands wrapped in asbestos gloves against metal that could sear flesh to bone. By dawn, they'll feed 1,000,000 rounds through those 10 guns. Not a single breakdown. The German position 2,000 yards distant simply ceases to exist. When the smoke clears, British observers find only churned earth where trenches once stood. No fortifications. No defenders. Just silence. The weapon that created that hell? It would serve Australian forces from Gallipoli to Korea, firing longer, harder, and more reliably than any machine gun before or since. When Australian forces landed at ANZAC Cove on April 25, 1915, they carried Lee Enfield rifles and optimism. The 2nd Australian Imperial Force had trained in Egypt, drilled on open desert ranges, prepared for conventional warfare against a conventional enemy. The Gallipoli Peninsula destroyed those assumptions within hours. Ottoman machine guns commanded every ridge, every gully, every approach. Turkish Maxim guns, older brothers to the Vickers, turned beaches into killing grounds. Australian infantry learned a brutal lesson. Without suppressive fire of equal volume, advancing across open ground meant death. The 4th Machine Gun Company deployed their Vickers guns on that peninsula, establishing defensive positions that would hold for 960 consecutive days of combat. But Gallipoli was merely training for the real crucible. By March 1916, over 60,000 Australians had transferred to the Western Front in France and Belgium. They arrived to find a stalemate that had consumed 2 years and hundreds of thousands of lives. German machine gun doctrine had evolved into something terrifying: interlocking fields of fire, concrete bunkers, belts of barbed wire 50 yards deep. The Somme offensive in July 1916 would see 57,000 British casualties on the first day alone, many mowed down by .08 Maxim guns firing from reinforced positions. The Australian divisions needed firepower. Heavy, sustained, never-stopping firepower. Every infantry battalion initially fielded just 4 Vickers guns. By 1918, that number had increased to 16, then 32. Machine gun companies became specialist units, 6-man crews trained to move, deploy, and maintain these weapons under conditions that would destroy lesser equipment. The guns had to fire through mud that buried men to their waists, through rain that turned trenches to rivers, through heat that made metal untouchable. And they had to keep firing when British officers ordered barrages measured not in minutes, but in days. The Western Front presented machine gunners with an impossible equation: sustain fire or die. German doctrine understood this perfectly. Their .08 machine guns fired the 7.92 by 57mm Mauser cartridge at 400 rounds per minute from positions that had been prepared for months. Concrete bunkers, steel-reinforced firing ports, ammunition stockpiles that numbered in the millions. A single German machine gun section could hold off an entire battalion if their gun kept working. British and Australian forces needed to match that firepower. But the tools available in 1915 presented serious limitations. The Maxim gun, predecessor to the Vickers, weighed 60 pounds without its tripod. Another 48 pounds of steel mount made it nearly immobile. Moving one required a 6-man crew and significant time. In fluid combat situations, that meant getting left behind. The Lewis gun offered mobility at 28 pounds fully loaded, but its pan magazine held just 47 rounds and the weapon's reliability suffered in sustained fire. After 200 rounds, the Lewis needed cooling. After 500, it needed maintenance. The Hotchkiss proved reliable but heavy, feeding from inflexible metal strips that slowed reloading precisely when speed mattered most. Every option presented the same fundamental problem: sustained fire generated heat. Heat warped barrels. Warped barrels meant jamming. Jamming meant dead gunners and overrun positions. Water cooling solved the heat problem but introduced weight. The .08 Maxim required 7 liters of water in its jacket, adding 15 pounds to an already cumbersome weapon. Gallipoli had taught Australian forces what happened when water ran out. Guns seized within minutes of continuous fire, their barrels glowing white-hot, mechanisms fused solid. The French Hotchkiss used air cooling and suffered catastrophic failures under sustained use. The Russian Sokolov mount made the Maxim slightly more mobile but no lighter. American forces wouldn't deploy their Browning M1917 until late 1917, and even then, it presented the same weight penalties as the water-cooled Maxims. Australian machine gunners needed a weapon that could fire all day and all night. They needed something that wouldn't jam when caked in mud. They needed reliability that exceeded anything else on the battlefield. They already had it. The Vickers machine gun story begins not with war, but with business. Vickers, Sons and Maxim Limited had purchased the Maxim gun patent in 1896, acquiring manufacturing rights to Hira Maxim's revolutionary recoil-operated design. But Albert Vickers, the company's chief executive, recognized that the Maxim, while reliable, carried too much weight for modern warfare's increasingly mobile demands. In 1912, the company's chief designer, whose name history has frustratingly obscured in favor of the corporate brand, began systematic weight reduction. Every component was examined. The heavy bronze water jacket became steel. The solid brass fittings became gunmetal. The receiver was redesigned with a lighter action spring. The lock was inverted to simplify production. The modifications reduced weight from 60 pounds to 33 pounds without water, a reduction of nearly 45%. More importantly, the changes increased reliability. The inverted lock design meant fewer moving parts. Fewer parts meant fewer failure points. The weapon maintained the Maxim's recoil operation, but simplified the mechanism to just 70 major components that could be field stripped and cleaned in under 5 minutes. The British Army adopted the Vickers MKI in November 1912, replacing the Maxim across all infantry units. It arrived just in time. When war erupted in August 1914, the British Expeditionary Force carried Vickers guns to France. Those weapons fired through the retreat from Mons, the First Battle of Ypres, and the subsequent trench deadlock that would define the Western Front. By 1915, British doctrine had evolved. Machine guns were no longer infantry support weapons. They were artillery. Australian forces initially received British-manufactured Vickers guns. The 4th Machine Gun Company deployed with their weapons to Gallipoli in April 1915, where one gun served continuously for 960 days, from the landing at ANZAC Cove through the evacuation, then to France, finally seeing its last action at Hamel in July 1918. That weapon, now in the Australian War Memorial Collection, bears serial number L6826 and the scars of nearly 3 years' continuous service. It never suffered a mechanical failure. By the 1920s, Australia recognised it needed domestic production. The Lithgow Small Arms Factory in New South Wales began manufacturing Vickers guns in 1929, building a 3-story facility specifically for machine gun production. Between 1929 and 1943, Lithgow would produce approximately 12,500 Vickers machine guns, the standard infantry MKI, the MKV aircraft variant, and the MKXXI tank version. These weren't mere copies. They were Australia's own. Technical breakdown. The Vickers MKI measured exactly 43 inches from muzzle to spade grips, shorter than a Lee Enfield rifle. The barrel alone extended 28.4 inches, encased in a fluted steel water jacket that held 7 pints of water when filled completely. Weight without water, 33 pounds precisely. With water, 40 pounds 6 ounces. The tripod mount added another 51 pounds, bringing the complete system to 91 pounds. Moving it required 3 men minimum, 1 carrying the gun, 1 carrying the tripod, 1 carrying ammunition and condensing can for water recovery. The weapon fired the .303 British cartridge, the same round used in Australian Lee Enfield rifles. This simplified logistics considerably. Any ammunition supply could feed both rifles and machine guns without separate stockpiling. The .303 round measured 7.7 by 56 mm, delivering a 174-grain bullet at 2,440 feet per second muzzle velocity. Effective range, 2,187 yards direct fire. Maximum range, 4,500 yards with indirect fire using dial sights. Rate of fire, 450 to 500 rounds per minute on average, though bursts could reach 600 rounds per minute for short periods. The ammunition belt fed from the right side, woven fabric holding 250 rounds in a continuous strip. Reloading meant simply attaching a new belt to the last round of the previous belt, no stoppage required. Experienced crews could maintain continuous fire indefinitely, provided they had ammunition, water, and spare barrels. The recoil operation was elegantly simple. When fired, the barrel and breech block recoiled rearward together, locked. After moving half an inch, the lock lifted, allowing the breech block to continue rearward alone. This extracted and ejected the spent case while cocking the firing pin. A return spring drove everything forward, stripping a fresh round from the belt and chambering it. The cycle completed in a fraction of a second. Water cooling was the gun's genius. The barrel sat inside a cylindrical jacket with a half-inch water gap surrounding the steel. When the gun fired, heat transferred to the water rather than air. Water has 4 times the heat capacity of air, absorbing tremendous energy before boiling. Even when it did boil, steam condensed in the flexible rubber hose leading to the condensing can, a 2-gallon container that cooled the steam back to liquid water, which could be recycled back into the jacket. This meant one filling of water could last hundreds of rounds. In the million-round test at High Wood, crews simply kept the jackets topped up from petrol cans filled with water from nearby shell holes. The water never ran out because the system recycled it continuously. Barrel changes required about 30 seconds with a trained crew. The barrel lock released with a quarter turn. The old barrel slid out the front. A fresh barrel, kept in reserve and wrapped in wet cloth, slid in. Lock. Done. Firing resumed. The Lithgow manufactured versions incorporated minor improvements. Australian engineers added slightly heavier recoil springs to handle the humid conditions of the Pacific Theatre. They modified the water jacket filler cap to prevent accidental spillage during transport. The tripod received reinforced legs after feedback from North African desert campaigns where sand infiltration had weakened the joints. But the core mechanism remained unchanged. It didn't need improvement. It already worked. Now, if you're finding this interesting, consider subscribing. We are building something here for people who actually care about the details, the engineering, the combat stories, the weapons that defined Australian military history. It takes a second, costs nothing, and helps us tell more of these stories. Gallipoli, May 19, 1915. 3 weeks after the landing. Ottoman forces launched a massive night assault against Australian positions at ANZAC Cove, 19,000 troops advancing in darkness to push the invaders into the sea. The 4th Machine Gun Company deployed their 4 Vickers guns on commanding ground, fields of fire pre-registered during daylight. When the attack came, the guns opened at 2,000 yards range. The Turkish assault simply evaporated. Ottoman forces suffered approximately 10,000 casualties that night, many from machine gun fire that never stopped, never wavered, never jammed despite hours of continuous operation. Captain Arthur Blackburn of the 10th Battalion recorded in his diary, "The Vickers guns fired all night. At dawn we counted the dead. They lay in rows where the bullets found them. The guns kept working." Western Front, August 1916. High Wood. The 100th Machine Gun Company demonstration wasn't just impressive, it redefined what was thought possible. Captain Graham Seaton Hutchison's unit fired 250 rounds short of 1 million rounds over 12 hours, using 10 Vickers guns. Using 100 spare barrels rotated continuously, they maintained constant fire on German positions at ranges exceeding 2,000 yards. Ammunition consumption, approximately 100,000 rounds per gun. Mechanical failures, 0. The barrels wore down from repeated firing, rifling lands showed visible erosion, but the mechanisms never stopped. Crews rotated every 30 minutes due to exhaustion, not equipment failure. The guns outlasted the men. German reports captured after the battle described the barrage as artillery fire from machine weapons. They couldn't believe machine guns could sustain such volume. North Africa, August 1942. Tel El Asa, Egypt. Sergeant Arthur Longhurst of the 22nd Australian Machine Gun Battalion saw a German tank approaching his position. No anti-tank weapons available. His solution: grab his Vickers gun off its tripod, cradle the 40-pound weapon against his hip, and advance alone toward the tank. The gun fired from the hip, not recommended procedure, but Longhurst had the strength and the desperation. He destroyed the tank's vision blocks and tracks with sustained fire, forcing the crew to abandon the vehicle. When Italian infantry attempted to support the tank, Longhurst swung the Vickers toward them, firing continuous bursts until the gun's barrel glowed visibly even in daylight. The Italian troops fled. Longhurst received the military medal. The Vickers gun went back into service without maintenance. It hadn't jammed despite being fired in a manner no manual would ever suggest. Korea, April 1951. The Battle of Kapyong. The 3rd Battalion, Royal Australian Regiment held Hill 504 against overwhelming Chinese forces. The battalion's 6 Vickers guns, positioned on commanding ground, fired throughout the night as Chinese infantry assaulted in human wave attacks. Ammunition expenditure exceeded 15,000 rounds per gun, fired in sustained bursts that lasted minutes at a time. The guns fired so continuously that crews had to wear asbestos gloves to handle the barrels for changes. Water in the cooling jackets boiled within minutes of starting fire. Condensing cans worked overtime, recycling steam as fast as it formed. By dawn, Chinese forces had suffered approximately 2,000 casualties. The Australian battalion lost 32 killed and 59 wounded, but they held their position. 3 RAS commanding officer later stated, "The Vickers guns saved us. They never stopped. Not once." Every gun remained operational at battle's end. Private Keith Crystal, who served with 3 RAR, recalled in post-war interviews, "The Chinese had machine guns too, copies of the Maxim. But they jammed. Ours didn't. That made the difference between living and dying." The combat record speaks with brutal clarity. The Vickers outperformed every comparable weapon system in sustained fire. The German MG42s, introduced in 1934 with its higher rate of fire, suffered from barrel overheating in prolonged engagements. The MG42, despite its fearsome 1,200 rounds per minute capability, required barrel changes every 250 rounds. The American M1919 Browning matched the Vickers for reliability, but weighed more and proved harder to maintain in field conditions. Only the Vickers could fire all day without stopping. The Vickers didn't just suppress enemy infantry, it fundamentally changed how Australian forces approached defensive warfare. By 1917, Australian machine gun companies had developed barrage fire doctrine, firing over the heads of friendly infantry to create a curtain of bullets that enemy forces couldn't penetrate. Using dial sights and precise range calculations, Vickers guns engaged targets beyond visual range, dropping bullets onto enemy assembly areas, approach routes, and supply lines. This transformed machine guns from defensive weapons to offensive artillery. A single Vickers gun could deny an entire hectare of ground to enemy movement. 4 guns, properly positioned with overlapping fields of fire, could create an impenetrable zone 2 kilometers deep. German tactical doctrine evolved in response. By 1918, German infantry avoided areas known to be covered by Vickers guns, even when no gun was visible. The psychological impact matched the physical casualties. The knowledge that advancing meant walking into sustained machine gun fire deterred attacks before they started. Australian divisional tactics increasingly relied on machine gun support. At the Battle of Hamel in July 1918, Australian forces used concentrated machine gun fire to isolate the battlefield, preventing German reinforcements from reaching the front line while Australian infantry advanced under the protective curtain. The battle, planned by Lieutenant General John Monash, succeeded in just 93 minutes, a stunning achievement attributable partly to precise machine gun employment. The Korean War demonstrated the Vickers' continued relevance despite being nearly 40 years old by 1951. While American forces had transitioned to the M1919 Browning and lighter air-cooled weapons, Australian battalions retained their Vickers guns for defensive operations. At Kapyong, Mariang San, and defensive positions throughout the war, the Vickers proved superior to more modern weapons in sustained defensive fire. By the time Australian forces deployed to Vietnam in the 1960s, the Vickers had finally been replaced by American M60 machine guns. But many veterans argued the change was unnecessary. The Vickers weighed more, required more crew, needed water, but it never stopped working. Sometimes older is better. Production and service life. British production of the Vickers Mk I began in 1912 at Vickers Crayford factory in Kent. Initial orders totaled just 2,400 guns. The British Army hadn't yet grasped how central machine guns would become to modern warfare. By 1915, production had expanded to multiple factories, with Vickers Limited, Metropolitan Carriage, and Colt Patton's Firearms all manufacturing guns for British Empire forces. Total British production exceeded 100,000 units by 1918. Australian production commenced in 1929 at Lithgow Small Arms Factory in New South Wales. The three-storey building constructed specifically for Vickers production included precision machine tools purchased from Britain, quality control stations that measured components to thousandths of an inch, and assembly lines staffed by workers who had trained at Vickers' British facilities. Lithgow's output: approximately 12,500 guns between 1929 and 1943. Cost per unit in 1940: approximately £42, roughly equivalent to 3,200 Australian dollars in 2026 purchasing power. The guns saw continuous Australian service from 1915 through 1968 to 53 years of operational deployment. Australian forces carried Vickers guns through both World Wars, Malaya, Korea, and early commitments in Vietnam. The weapon's reliability meant many guns served for decades without replacement. The 4th Machine Gun Company's gun from Gallipoli, serial number L6826, served continuously from 1915 to 1918, then remained in reserve stocks until the 1940s. When Australian forces finally retired the Vickers in 1968, replacing it with the Belgian MG42s, manufactured as the M60 in America, many veterans protested the change. The M60 offered lighter weight and easier deployment, but early models suffered reliability problems the Vickers never experienced. Surviving examples now reside in museums worldwide. The Australian War Memorial in Canberra holds multiple Vickers guns, including the Gallipoli veteran. The Lithgow Small Arms Factory Museum preserves several Lithgow-manufactured examples. Private collectors in Australia possess approximately 40 registered Vickers guns, deactivated but preserved as historical artifacts. A functioning, transferable Vickers machine gun commands collector prices between $15,000 and $22,000 in American markets where such transfers are legal. In Australia, deactivated examples sell for $3,000 to $8,000 depending on condition and provenance. Some Vickers guns remain in service even today. Reports indicate armed forces in Africa and Asia still deploy Vickers guns in defensive roles. Weapons manufactured 80 or 90 years ago, still working, still firing, still reliable. The gun truly never stopped. The Vickers established principles that define machine gun design even now. Sustained fire capability matters more than rate of fire. Reliability outweighs weight savings. Simple mechanisms outlast complex ones. Modern general-purpose machine guns like the FN-MAG inherit the Vickers philosophy even while using different operating systems. The MAG weighs 24 pounds, less than the Vickers, but its design emphasizes sustained fire capability through quick-change barrels and robust construction. The American M240, used by U.S. forces today, is simply a licensed version of the MAG, and it can trace its doctrinal lineage directly to the Vickers. The Soviet PK machine gun, introduced in 1961, adopted similar sustained fire doctrine despite using a completely different Kalashnikov-derived mechanism. Chinese weapons like the Type 67 GPMG show clear influence from Maxim Vickers design principles, prioritizing reliability in adverse conditions over modern weight reduction. Military historian Dr. John Peaty, writing in the Journal of the Royal United Services Institute, noted, "The Vickers machine gun established the benchmark against which all subsequent machine guns must be measured. No weapon before or since has equaled its combination of reliability, sustained fire capability, and operational longevity." The weapon influenced doctrine as much as hardware. British and Commonwealth forces developed machine gun tactics that American forces later adopted. The concept of beaten zones, fixed-line fire, and defensive firepower concentration all emerged from Vickers gun employment on the Western Front. Australian military doctrine still emphasises sustained support fire, a legacy directly traceable to Vickers gun operations in both World Wars and Korea. The Australian Army's machine gun training emphasises crew drills, maintenance, and fire discipline that originated with Vickers gunners a century ago. In 2016, British Army armourists conducted a final test of a 1917 vintage Vickers gun at Strensall Barracks. After a complete restoration and replacement of worn parts, they fired 5,000 rounds in a continuous test. The gun, 99 years old, worked perfectly. Some legacies never fade. 33 pounds of steel. 7 pints of water. A mechanism so simple a blindfolded man could assemble it. This was the gun that fired 1,000,000 rounds without breaking. This was the gun that Australian soldiers carried from the beaches of Gallipoli to the hills of Korea. This was the gun that crews refused to abandon even when offered newer, lighter weapons. The Germans had the MG34 and its terrifying MG42 successor. The British eventually moved to air-cooled Bren guns. The Americans deployed their Brownings by the thousands. But Australia had the Vickers. And for 53 years, across 4 wars and 3 continents, when Australian forces needed firepower that absolutely would not fail, they turned to that water-cooled workhorse that simply refused to quit. The gun that never stopped.